In this module, we're going to talk about data visualization. As we go through this, think about how you can use this in your own work. This module will be fun, but a lot of it's going to be theory, so sit back and relax and enjoy. We're going to talk about visual perception. So what is visual perception? It is the interpretation of processed information that we are receiving from the visual world. So what does that mean? Well, let's work backwards. If we start with our sun, it's going to send its light rays down onto an object, and those light rays are going to bounce off that object and into our eyes and down through our optic nerves. So this is the visual world. Our brain processes this information, and then it is available for interpretation. The important takeaway here is that there are a lot of processes that happen between the visual world and our brain. That means that what we see in the world isn't necessarily what's there. And we want to make this point very clearly early on, because when you present data, how you present that data will affect how it's perceived. Do not think simply because you have data and you represent it in a certain way that is exactly how everyone everywhere is going to receive it, or that it's going to be received as you intended it. So keep that in your mind as we move further. So how many sevens can you count here? Take a second and count them. Now, I'll be honest with you, I don't entirely know how many sevens there are, but I do know that they'll be easier to count if I highlight them. So in this case, we are highlighting the signal. So if everything else is noise, we are raising that signal above the noise. And we're making it easier to count what we need to count. So think about this in your presentations of data. Are you making it easy for the person looking at your dashboard or your data visualization to understand what's going on? Or is there a lot of extra noise that prevents that from happening? And as you look at this, it's much easier to count, and even now, it's even easier. So there are things you can do, like having a common baseline, that can make the processing of information a lot easier. Just to really prove to you this idea that what we see in the world is filtered by our brains, well, we can see this right now. I have a very common optical illusion. It's a series of squares with the same color on top of a gradient. And those squares are all the same color. Let's just prove this. If I put those squares down there and I move that gradient down below, we see that the gradient changes how we interpret those colors. So again, there's this idea that what we have in the visual world comes in through our brain and we process it. And depending on the context is how we interpret it. So as you might imagine, contrast plays a significant role in what we think is lighter or darker. So let's talk about the third dimension for a second. Take a look at this chart. Which wedge do you think has the greatest proportion? Well, it kind of looks like the yes one does. What happens if we change perspective? Now it looks like the no one does. What happens if we just take away perspective? We see that they're equal. And let's continue on this theme of the third dimension. So if I asked you to take a look at region B and tell me how representative 2 performed in selling product C, how hard would that be? Now compare that to representative 1 in region B selling product C. It's nearly impossible. So as both these previous examples demonstrate, the third dimension can actually make things a little worse. And in fact, I will argue to you to not use the third dimension at all. You don't really need it. It doesn't make reading charts easier. In fact, it makes it a lot harder. And if a chart exists to be read, to be understood, to help identify problems in a process or improvements, or really just to understand what's going on, this chart fails. And we don't like making failing charts. So what can we say about all of this so far? Well, we know our brains are very receptive to certain patterns. And if we know what those patterns are, and we're going to talk about them later in this module, then we can use them to our advantage. And in fact, we have a cognitive ability to link disparate information. Finally, we know that visualization can help us get an understanding of data if we use it properly. If we don't use it properly, we don't know what's going to come out of it. It might not necessarily be the message we intended. So take a look at this table. If I were to ask you to pick the second highest amount in this table, what would it be? Now that wasn't so hard, but I want you to consider the process of doing it. What you had to do was you had to store January's value in your memory, and then you had to move on to the next one, and you had to compare it, and you had to keep doing that, and then you had to store really two values, which was the highest and which was the second highest, but was also higher than everything else. This process puts information in our working memory. Our working memory can only hold so much. So imagine that this was a much larger data set. There are things that tables can't really show us as well as data visualizations. Watch what happens if I visualize this table. Now if I asked you which month had the second highest amount, you'd be able to identify it immediately. It's June. But there are also other things we can see on this immediately. Again, we can see that the lowest price was in April, that the highest point is at the end of the series, and finally we can see that there's some seasonality, that there's some cyclicity with this data, that it ends up going up, up, January, February, then down in March, up again, in April and May, down in June, and down again from June to July. These are things that we can see immediately. Let's take a look at this chart. Now, most of you are probably familiar with correlation analysis and how it works. So what we have in this chart is we have work experience on the x-axis and salary on the y-axis. All this data is made up just for example purposes, but let's imagine a survey was given out and asked two questions. How much work experience do you have, and what was your salary? And what we see with these data points is that there's a common theme, that the more work experience you have, the higher salary we can make. And in correlation analysis, what we're saying is that we think that there's some sort of underlying natural relationship there. We feel like we've captured it a little bit with these data points, and we think we can approximate it by drawing this line through. And it may not be perfect, but we could probably get very close to it. So whenever we draw a line through something, we often are interested in the fit of that line. That is, how well does it fit this data? How well does it explain the variation? And that number is usually given by r squared. And there are other ways to do it, but r squared is the one we're going to use here, because I want to make this point. So as we look at this chart, this r squared seems to make sense because the line does seem to fit nicely through these scatter points. Now let's take a look at these sets of charts. This is ANSCOMBE'S QUARTET, and ANSCOMBE was a statistician from way back in the day, and he wanted to show the importance of data visualization. And he did this by showing several different charts and having the same line go through it. And the interesting thing about this line is that it all has the same r squared. So if we were just going by that number, that r squared, to say what the fit is, we would miss the problem. The fact of the matter is that this first chart feels pretty good. This is what a line of best fit should do. This chart here is not. It is not explaining this underlying pattern. And in these other cases, we have outliers. Or in this bottom case, the pattern may not necessarily be as good a fit as we think. So the important thing that I want to draw your attention to here is that without data visualization, this number would mostly be meaningless. So we can consider data visualization not as something that saves us, but rather as a tool in our arsenal in delivering information.